myself comfortable here. All right, if we move on to 4.3, solving polynomial inequalities. So we started solving inequalities and we just did linear ones in 4.2. With 4.3, we're going to go beyond linear, so we'll go to quadratic, cubic, quartic. So what that does is bring back a whole bunch of topics from chapter 3. So we're going to have to remember how to do synthetic division. We're going to have to remember how to factor using a difference or a sum of cubes. So all those building blocks from chapter 3 are going to come back in the 4.3 lesson. Just a reminder, if you're watching this 4.3 lesson, this is the last lesson of chapter 4. We've cut out 4.4, which was rates of change, only because we already assessed you on rates of change in chapter 2, so we have to trim where we can, so that's one that we're going to trim off. So if you look, the 4.3 lesson that's in your in the package on D2L kind of looks like this. There's 3 pages to it. Okay, so I'm going to go through the majority, not all the written stuff, but all the math for sure, to make sure we can remember some of those big concepts. So in the first example, it's set up in factored form just so we can outline very, very carefully what it is we're trying to do. So this is similar to something you would have seen in other years, other grades, but before we had an equal sign, we always dealt with equalities. It's this course the first time you've had to deal with inequalities in any sort of way. But the way that you want to deal with an inequality is to look at the zeros of the equality. By looking at the zeros of the equality, you'll see what we consider to be points that you can assess to see if the sign is changing or not. Which means, is it going from positive to negative, from negative to positive? Is it staying positive in both sections? Is it staying negative in both sections? You can have some general ideas of what's happening. So what you're going to do is if it's in factored form, great. If it's not in factored form, you're going to have to get it into factored form. And again, you'll have to use synthetic division, or you'll have to use difference of cubes or sum of cubes. You're going to use different, depending on the question, different ways that you can factor things. So once it's in factored form, we first want to think if this was an equality, so change it from greater than to equals, what would the zeros be? And use the zero product property. If all of these multiplied together gave an answer of 0, then one of them would have to be 0, right? So if x plus 3 equaled 0, then x would be negative 3. If x minus 1 equaled 0, then x would have to be positive 1. If x minus 4 equaled 0, then x would have to be positive 4. And then I'm going to take those 3 zeros and just plot them on a graph. We know those are where they cross the x-axis. Okay, well, it might not cross, it might come back down, but those are definitely points on the graph of this particular function. So I put a dot at negative 3, at positive 1, at positive 4. Okay, and now we're going to be looking, is it going from less than 0 to greater than 0 to less than 0? Is it staying on both sides? Is it both times going to be positive or both times going to be negative? And the way that you can assess this is to set up a chart of the intervals. And by intervals, I mean start on the left side of the graph. The first interval is anything less than your most left 0. So the most left 0 on here is a negative 3. So our first interval is anything less than negative 3. Our next interval goes between these two zeros. So between negative 3 and positive 1. Okay, our next interval goes between the next two zeros, between 1 and positive 4. And then our last interval is anything to the right of your largest 0. So this one is going to be anytime x is greater than 4. So if you have 3 zeros, you'll notice 4 intervals. If you had 2 zeros, you'd have 3 intervals. If you had 4 zeros, you'd have 5 intervals. There's always one more interval than the number of zeros that you see present. Okay, and there's a couple different methods for how you can set this up. I'm going to try to set it up in the most straightforward method, especially because we aren't in a classroom. Once you have it in factor form, take each of the individual factors and list them in their own row in the chart. Okay, then you can recombine them the way they're sitting in the very last row. Now I've put a double line here because that sort of represents the ending. Like if I put them all together, this is really truly the answer you're looking for the interval. What this is doing is splitting up into parts so you don't have to do too much thinking. Okay, so this is saying, I'm going to look at this part of the function, x plus 3, in each of these 4 intervals, and what I want to list is the function positive or negative there. Because remember, my goal is to find out if it's greater than 0. Okay, we know that it's not a 0. We've already established those, so it's either going to be greater than 0 or less than 0. So that's all I'm establishing. Is it positive or is it negative? So here we have to pick an x value less than negative 3. And you can pick anything you want. Something less than negative 3, let's just pick an integer like negative 4. If I sub negative 4 into here, negative 4 plus 3 is negative 1. That's a negative term. And all you're going to put is positive or negative symbols in here. Okay, move to the next interval. Or let's just keep negative 4 and do all these first. Let's just do the first column. So I picked an x value of negative 4. I'm going to plug it into each of these 3 things. Okay, so when I plugged it in here, negative 4 plus 3 was negative 1. Negative 4 minus 1 is negative 5. It's a negative number. Negative 4 minus 4 is negative 8. It's a negative value. Now here, this is the part that's important. You want to see when I put the function back together, in which case it's all a multiplication, do I get a positive or a negative? So in this case, I'm multiplying a negative by a negative, which pops out a positive, multiplied again by a negative, which will give me a negative value. Okay, and so for these charts, you're just going to do that for each column. Pick a value between negative 3 and positive 1. So I pick something like 0. Okay, 0 is a value between negative 3 and positive 1. I put 0 in here. 0 plus 3 is 3. It's a positive number. I put 0 in here. 0 minus 1 is negative 1, a negative value. I put a 0 in here. 0 minus 4 is negative 4, which is a negative value. You do the multiplication, which is what this function is. Positive times a negative is a negative. A negative times a negative pops out a positive. So when you multiply all 3 terms together, a positive number by a negative number by a negative number, you get a positive. Okay, same thing here. I'm going to go over what happens between 1 and 4. Okay, I'm going to pick any value between 1 and 4. You might as well pick integers. I'm going to pick 2. 2 plus 3 is 5, positive number. 2 minus 1 is 1, a positive number. 2 minus 4 is negative 2, a negative number. Multiply a positive by a negative, and we get a negative. Okay? Last interval, x is greater than 4. Let's pick 5. 5 plus 3 is 8, positive value. 5 minus 1 is 4, a positive value. 5 minus 4 is 1, a positive value. Obviously, a positive multiplied by a positive is a positive. So what this tells us, if we go back to where this graph is, and you can actually take some test points and see where it's turning in different areas to be more accurate. But at this stage, we're just looking and we're saying, okay, when x is less than negative 3, the whole function is negative, which means it's less than 0. It must be down here. But then when you're between negative 3 and 1, you're up in the positive somewhere. Okay? When you go between 1 and 4, you're back down in the negative. And then when you are greater than 4, you're back up in the positive. That's how I knew these had to turn, because we were going from negative to positive to negative to positive. Okay, you can sub in exact values. Like if I put a 0 in here, then I get 3 times negative 1, which is negative 3, times negative 4, which is positive 12. So for instance, I know this is the coordinate 0, 12. Okay, you could do the same thing to find out what happens down here, where exactly it's turning, to get a better idea of what's going on. Okay, but this is the general idea of how a question like this gets solved, and it's really all about the chart. Okay, you cannot build the chart until you've factored it, but factoring is, again, something that we did in chapter 3. So if you feel fairly proficient at factoring, you shouldn't have too many problems. Because once you get in factored form, you just build the chart and literally substitute in a point of your choice and see whether it's positive or negative. Okay, so that takes care of the first 2 pages. On the last page, there are some notes which are fairly important, and I should talk about a couple of them. At this, it says specifically, notice that at each 0, this polynomial happened to change sign. So it went from negative to positive to negative to positive. But it could be a situation where it's positive here and then it's positive again. Okay, so it might stay up here and then be another hump that way. It doesn't have to go through the 0. It might just hit the 0 and come back up. So just be aware that's a situation that could happen. You may have to use the quadratic formula to find the zeros. You might get down to a quadratic, so a squared function. It doesn't look factorable in terms of having integer answers, and you may have to find the zeros using the quadratic formula. Shouldn't be a problem. Now with the quadratic formula, you may get non-real answers, which means you have a negative under the square root. If that happens, then we're not going to use those zeros, obviously, as an interval. Okay, so if you use the discriminant, b squared minus 4ac, and find out that you're going to have no zeros at that situation, then we don't need to use it. This example is already factored and set up with the zeros on one side. If it's not, you have to make it so that it either says greater than or equal to, less than or equal to, 0. There can't be anything else on the right side other than a 0. The rest of the function has to come to the left side, and you have to deal with it over there. Well, this method will work when the inequality is linear. It is overkill. Use the methods from previous lessons. So if it's a linear one, just do what we did in 4.2. This is only when you have a polynomial of degree greater than 2, usually even. If it's of degree 2, just use the quadratic formula. So this is for cubic and above. Okay, so polynomials where you're talking about cubic, quartic, quintic, anything above that. Okay, there are 2 examples on there, which will be filled out for you online as well, but I want to run through them with you so you can kind of at least get a little refresher on how to use synthetic division and how to use a factoring and difference of cubes. Okay, so we'll do both those examples, and then that's it for chapter 4. And really chapter 4, 4.1 through 4.3 is all we're doing this week. So on Thursday, April, I don't even know what day it is anymore. Thursday, April 16th, I'll release the chapter 4 assignment, very similar in length to what we did last week. And then you can hand it in by Friday, and that'll be the last thing that goes into our midterm marks. Okay, so the 2 examples they have here. Solve the following. Okay, so I don't need to write what it says. The first one is x to the 4 minus 8x is less than 0. Okay, so a couple things are already worked out here. It already has the 0 on the right hand side, so we don't need to worry about that. We just have to look at this and figure out how to factor it. So many moons ago I did teach grade 10 math, and I remember specifically some things that grade 10 struggled with was the idea that you have to common factor first. If there is an area where you can common factor, do that. It makes your life easier. So right away when I look at this, I say, oh, they both have x's. Okay, so take an x out. I know that an x can be common factored out. What's left is an x cubed here, right? When you divide x into x to the 4, you're left with x cubed. When you divide x into negative 8x, you're just left with the negative 8. Okay, so when you get that first sort of thing, you now recognize that this here is a difference of cubes. Okay, x cubed minus 2 cubed. Okay, and there's, again, a specific rule that says when you are doing a difference of cubes, you take the cubed root of this, x, you take the cubed root of this, 2, that gets a minus sign, and then you do a similar thing. You have an x squared, what was left over, then you multiply the 2 together, so this was 2 and x, put a plus sign, and then 2 squared, which is 4. Okay, so when you get this, this is now in factored form, and you say, well, can I factor this one? Can I find 2 numbers that multiply to 4 and add to 2? Definitely not. Should I try the quadratic formula on this? You can, but somewhere in your head, if you just think for a moment about what that's going to mean, if I try to look at this case at the discriminant. So the discriminant is something you need to remember from grade 11. It's what's under the square root sign in the quadratic formula. If I'm just looking here, my b value is 2. 2 squared minus 4, 1, 4. I get 4 minus 16, which is negative 12. What that means is there's a negative under the square root sign in the quadratic formula, which means it has no zeros. So it's not that we don't consider this in the whole function, we just don't consider, this has no bearing on the zeros. Okay, so what we would really be looking at here in terms of what are the zeros, we could simply say, if we looked at this entire function, x minus 2, the only possible values that can make it equal 0 come from these two terms. So either x equals 0 from here, or x equals 2. Okay, that means these are the only two values we're going to use to set up the intervals. Okay, we're not using this part, because this doesn't give us zeros. There are no zeros from this particular thing. There's no x value you could possibly substitute in here that would give you an answer of 0. Okay, it's not going to happen. Okay, so these are the only two values that are giving us true zeros, so these are the ones we're going to use for the intervals. So again, now that you've factored it, you set up the chart. So the chart looks like this. You go to your very leftmost value, and you want to be less than 0. Okay, then the next interval is between your two values. 0 is less than x is less than 2. And your last interval is greater than 2. Sometimes it's easier for people if they set up a little grid. So you see you have zeros right at 0 and right at 2. So you know your first interval has to be to the left, your second interval in the middle, your third interval on the right. You can do whatever you want. Okay, and then again, we're going to set up here all parts of this factored form. So really, we have three parts. We have the x, we have x minus 2, and then our last part is x squared plus 2x plus 4. We still have to consider this in the solution, of course. It just didn't help us to determine what the zeros were. It didn't help us with the intervals, but it's still part of the function. Okay, so then I like to put a double line to remind myself this is where I have to multiply. And then these are all the parts. X minus 2, x squared plus 2x plus 4. Okay, and again, you just pick values and then go about looking at whether it's going to be positive or negative. So here, you want to pick a value less than 0. So if I pick negative 1, I put it in there, it's a negative 1. So that's a negative value. I put a negative 1 in here. Negative 1 minus 2 is negative 3. It's a negative value. I put a negative 1 here, and maybe you have to do some math on the side. Negative 1 squared plus 2 times negative 1 plus 4. 1 minus 2 plus 4. I get 3. 3 is a positive value. I put it there. Okay? You have to show this work? No, not by any means. If you want to do a scrap piece of paper, fine. When I multiply these all together, a negative times a positive is a positive. Okay? Do that for all the intervals. Okay? Pick a value between 0 and 2, the most obvious one being a 1. Put a 1 there, positive. Put a 1 here, 1 minus 2 is negative 1. Put a 1 here, everything's positive. Goes about and you get a positive answer. Multiply a positive by a negative by a positive, and you get a negative. Pick an x value greater than 2. An x value greater than 2 is something like 3. Put a 3 value in here, obviously positive. Put a 3 value in here, 3 minus 2 is 1, positive. Put a 3 in here, again, everything's already positive, stays positive, and my answer is a positive. Now, you have to remember what the question asks you. And I don't think I even talked about this in the last example, so this is important. It asks for you, when is this less than 0? Well, it's positive here, it's negative here, it's positive here. What does less than 0 mean? Less than 0 means it's negative. Therefore, this function, x minus 2, x squared plus 2x plus 4, is less than 0 on this interval from 0 to 2. Okay, so you can use that notation, or you can write it in interval notation like this: 0 less x is greater than or equal, greater than 0, less than 2. Either one of those is fine to say. So remember, interval notation is fine in either capacity. So it's not good enough to just fill in the chart. You have to actually answer the question, and I failed to do that on the first one. The first one said, when is it greater than 0? So you would have picked the two intervals that it was greater than 0. Okay, between -3 and 1 and greater than 4. Sorry, my mistake. Okay, once you do a couple of these, you'll get really, really used to the idea of setting up the chart, checking where it's positive and negative, and then remembering to answer the actual question. Okay, one more example, and then 4.3 is done. Okay, in the last example, obviously I wanted to do one where we had to re-establish how exactly to do synthetic division. So just to remind us about synthetic division. Okay, so the last example in here, and I can barely see, even though I have glasses, x cubed minus x squared. Now this is the first time we've seen greater than or equal to, but it's not going to change the way we do the question. This is also the first time we've seen something on the right side of the equation. Also does not change what we are doing. Okay, so the main goal, this adds a step. The step is bring everything to the left side of the equation. We want this over here to say greater than or equal to 0. That's the goal. So when you bring this over, when I bring the negative x cubed over, it becomes positive. I've written it here because I still want to keep them in order, sort of. So the next thing is x squared minus 3x. When I bring this 2x over, it becomes negative, plus 3. When I bring this 5 over, it becomes negative. Okay, so I brought them in order to the other side just so they're already grouped in like terms. X cubed plus x cubed, 2x cubed. Minus x squared minus 5x minus 2 is greater than or equal to 0. Let me make sure I got that all right before I mess anything up. Okay, perfect. So we need to now factor this. Well, this is a cubic function. Up until a couple weeks ago, we didn't know how to factor cubic functions, and this is where we said, well, this is where we start in synthetic division. And with synthetic division, we sort of have to look at this function. Let's call it f of x. Let f of x equal 2x cubed minus x squared minus 5x minus 2. And remember, the whole goal is to find a value of x where this is 0. Because that's what it means to be factoring something. You're trying to find the zeros. So this one specifically, because I have the solutions in front of me, it's going to be -1. Let's just make sure. -1 cubed. So I get -2 minus 1 plus 5 minus 2, and it is in fact 0. Good. So we know that x plus 1 is a factor. Okay, what does that say? That means we can set up our synthetic division. We can put the -1 out here, right? We can list the coefficients that we had. 2 was in front of x cubed, -1 in front of x squared, -5 in front of x, and -2 here. And then we will do the synthetic division. We pull this down, and we get a 2. 2 times -1 is -2. Add, multiply, add, multiply, and again, you want to get a remainder of 0. So what we have now in terms of this function is x plus 1, and then this, 2x squared minus 3x minus 2. And we're trying to find out when is this greater than or equal to 0. That's our whole goal. Okay. Oh, it's pouring rain outside. You may or may not be able to hear it. Okay. This is great. We know one of our zeros is -1. We still don't know what the 0 is for this. But this is a quadratic. I don't need to use synthetic division anymore. I can just factor that. I can just set this up and say I need to find, let me see, I'm going to put a -2 here, a +1, right? 2x times -2 is -4x, and 1x is -3x, So this is how that factors. If you don't understand how this factors to that, you gotta go back to grade 10 or 11. We don't have time for that. So when we look at what this means in terms of what we're doing, x plus 1, 2x plus 1, x minus 2. We will eventually be looking for when it's greater than or equal to 0. But let's just for a moment let it equal 0. Okay? If we let that equal 0, then we know the following about the zeros. X equals -1, or this one you have to do a little bit of thinking, bring the 1 to the other side, becomes negative, divide by 2, or x equals -1/2, or x equals 2. So again, we have 3 different zeros. And if you were looking on a grid of some sort, where you had values and put a -2 here, a -1, a 1, and a 2, we now know that this has zeros at -1, -1/2, and at 2. So we're going to be looking at 4 specific intervals. The one less than -1, between -1 and -1/2, between -1/2 and 2, and greater than 2. Okay, so we want to look at 4 different intervals. There's 3 zeros, so we need 4 intervals. Okay, so I'm just going to leave that there for a moment. I'm going to have to do the chart up here. Let's see what's happening. So what I'm going to do is get us, what part do I want to leave? I want to leave that has the question. We want to figure out where it's greater than or equal to 0. It's actually storming outside. This is Monday afternoon. I left my kids inside, so 100% they're not going to come out now. Unsupervised children. Okay. So when we set up the chart, we again have to look at these values. So x is less than -1. That's the first part. Between -1 and -4.5. Woo. Between -1/2 and 2. And then x greater than 2. 4 different intervals. And we have 3 factors. We want to put all 3 of them in. And then I put the double line, which is our function. So our 3 factors are x plus 1, 2x plus 1, and x minus 2. Okay, and then this is them all multiplied together. So I don't have a lot of room here. Okay, and then you just go about and do the exact same thing you did before. Pick an x value less than -1. If I pick -2, -2 plus 1 is a negative. If I pick -2, -4 plus 1 is a negative. If I pick -2, I get a negative. When I multiply a negative by a negative by a negative, I get a negative. Remember, these are the important ones. The ones I'm doing in red are the ones we care about. These just help us find that one. Okay, picking a value between -1 and -1/2. So now you have to pick not an integer. You're going to have to pick some other sort of rational number. Maybe you want to pick -3/4. Okay, can you put it in as a decimal? For sure. You're just testing your own point. So if I put -0.75 plus 1, ooh, I get 0.25, that's a positive. -0.75 times 2 is -1.5 plus 1, which is a negative. If I put in -0.75 minus 2, they're both negative, so that becomes a negative. Positive times a negative times a negative is a positive. Okay? Continue. Pick a number between -1/2 and 2. Well, this is a huge range. Pick something easy, 0. If you can pick 0, it's usually the easiest one to do. 0 plus 1, positive 1. 2 times 0 plus 1, positive 1. 0 minus 2, negative. Positive times a negative is a negative. Okay, and the last interval, pick an x value greater than 2. Let's pick 3. 3 plus 1 is 4, that's a positive value. 2 times 3 is 6 plus 1 is 7, that's a positive value. 3 minus 2 is 1, that's a positive value. Positive times a positive times a positive is a positive. So we're back to a function that's every other. Less than 0, greater than 0, less than 0, greater than 0. There's lots of bending going on here. There's going to be turning points all over the place. So the question is, and this is the part you have to make sure you don't mess up like I did on the first one. You're trying to state when is it greater than or equal to 0? okay? It is greater than or equal to 0 on this interval and on this interval. But it's not when is it greater than, it's when is it greater than or equal to. Okay, so you have to include the zeros this time. So you either say -1 is less than or equal to x is less than or equal to -1/2. If you're using bracket notation, you're going to put the square brackets. Okay, and it's also greater than or equal to 0 when x is greater than or equal to 2. And again, you could do that 2 to infinity. Okay, so the question was, when is it greater than or equal to 0? So you would say, therefore, x plus 1 times 2x plus 1, or you can go back to the original question, doesn't really matter, is greater than or equal to 0 in the following, yeah. When x is between -1 and -1/2, inclusive, that means include -1 and -1/2, or when it's greater than or equal to 2. And again, you can use inequality notation like this, or you can go back and use the notation we used starting in chapter 1, which I think people were fairly comfortable with this, so if you want to continue with that notation, that's perfectly acceptable. Okay, I think that's good. Do a couple questions from the homework. I would attempt to do as many as you can that were assigned. I'm going to amend the practice test a little bit to exclude questions that had 4.4 in them, and then that's it for your week. So yeah, Tuesday, Wednesday, you have time to do 4.3 in the practice test, and then starting on Thursday, you can start doing the actual assessment, but remember, it won't be due till noon hour on Friday. Okay, thanks guys.